prove by induction that the sum of r times 2 to the power r over r plus 2 factorial equal to 1 minus 2 to the power n plus 1 over n plus 2 factorial. First, we show the base case to show that the statement is true for n equals to 1. And then we look at the left side and the right hand side. And for the left side, because n is 1, so r is going to be 1. And we put 1 here times 2 to the power 1 over 1 plus 2 factorial. And 1 plus 2 is 3. So we get 2 over 3 factorial, and that equals to, 3 factorial is 3 times 2 times 1, which is 6. So that's 2 over 6, which is 1 over 3 when simplified. Now I want to do the same for the right hand side here. We have 1 minus 2 to the power 1 plus 1 over 1 plus 2 factorial. That will be 3 factorial, and 3 factorial is 6. 2 to the power 2 is 4 over 6. That's 1 minus 2 over 3. Multiply that by 3, multiply that by 3, and we get 3 over 3, which is still 1, but we're making them same denominator. Therefore, we have 1 over 3. So that's true for 1 over 3 there. Because they're the same, well, that shows that the statement is true for n equals to 1. Part 2, inductive hypothesis, where we assume the statement is true for n equals k. Here's the equation again, and now we're going to replace n with k. So we're transforming n to k. So we got k here, just there, and we're going to put k here and k there. Now we're going to use this step 2, which is inductive hypothesis. Part 3, the inductive step. We need to prove that the statement is true for n equals to k plus 1. Write down the equation again, and this is where we're going. We want to show that n equals k plus 1, so we want to replace that with k plus 1 and that with k plus 1. 1 minus 2 to the power k plus 1 as k plus 2 divided by k plus 1 plus 2 is k plus 3 factorial. And so we showed the transformation from n to k plus 1 to replace n with k plus 1 as k plus 1 equal to, now we're going to get from step 2 where we get the 1 to k, that's from step 2, k plus 1. The r is replaced with k plus 1. That's the last term, k plus 1 for r there, and k plus 1 there. So we got the 1 to k term, and then we're doing the last term, which is k plus 1 term. But this is what we need to show. We need to show this. In the second step, we had shown that with n equals to k. In the second step, we just replace that with k. To use that now with this one here plus last term. And now we need to simplify this so that we can get that. This is k plus 3 factorial, and this is k plus 2 factorial. I want to make these the same denominator. The 1 is there, so I'm going to leave it. I'm going to make that the same denominator as that, so I need to convert that to k plus 3 factorial. But we do know that k plus 3 factorial is k plus 3 times k plus 2 factorial. Here's an example. 4 factorial is 4 times 3 times 2 times 1. And we can rewrite that as 4 times 3 factorial. 3 times 2 times 1 is 3 factorial. So you can see, if you have 4 there, factorial, you still got 4 times 3 factorial. Hence, that's what's happening here. So this will be k plus 3, which is the 4 factorial, 4, and then 1 less, which is 3 factorial, k plus 2 factorial. I need to change that to k plus 3 factorial, yes, by multiplying this by k plus 3 and that by k plus 3. So I'm going to times this by k plus 3 and that's by k plus 3, and then plus this one here. So I've got that is k plus 3 in the denominator, factorial. And then we get k plus 1, 2 to the power k plus 1 over k plus 3 factorial minus, so what I did is I wrote that first and I'll put that next, minus this one here. That'll be k plus 3 factorial and k plus 3 here, 2 to the power k plus 1. That's now k plus 3 factorial. So I've just switched this around with that. I'm going to take out minus 2k plus 1 over k plus 3 factorial. We take out minus 2 to the power k plus 1 over k plus 3 factorial. Let's use a square bracket. K plus 3 left minus k plus 1. Now if I expand this, k minus k will be gone. 3 minus 1 is 2. So 2 to the power 1 over k plus 3 factorial. Same base, you add the power. 2 to the power k plus 1 times 2 to the power 1 will be 2 to the power k plus 2 divided by k plus 3 factorial. That's correct. That's what we are hoping to get, and that's what we got, and that's the final answer. Step 4. You must write the 4-point statements to get full mark. First one, since the statement is true for n equals 1, you have to write it down. And if the statement is true for n equals to k, then it is true for n equals to k plus 1. The statement must be true for all n greater or equal to 1. All 4 statements must be written down to get the full mark.